Hey guys, welcome to my channel. I'm LeetCode. If you guys are new here, I pretty much do LeetCode style questions and explain things in the simplest way possible. Today we have a pretty interesting problem that I'm very excited about. So let's go ahead and read the problem statement. So the problem is called the word search, right? It says given an m by n grid of characters, right? Called board, right? And a string word. Return true if word exists in the grid, right? Pretty much that's they're telling us that they're gonna be giving us a board, right? Then a word, right? And then our job is to pretty much find if that word exists in the board. I'm saying it says the word can be constructed from letters of sequentially adjacent cells, right? Where adjacent cells are horizontally or vertically neighboring, right? The same letter cell may not be used more than once. Okay, so they're saying that we need to find a way to construct the word, right, in the board, right? By using the neighboring cells. What I'm saying in neighboring cells, meaning that cells that are horizontal, I'm saying, and vertically. So this is good, and this is good. This direction is good. I'm saying up and down, left to right are good directions. I'm saying so that's a good path. You know what I'm saying so this one, right? That's a path that leads to that word that we're looking for. So this is the board, right? And this is the board, right? This is the word that we're looking for, guys. So and you can see this path is the path that leads to that word. I'm saying. And then this one, same thing, right? They're looking for this word, what I'm saying. And then you guys can see nothing, right? There's no S. And you see this one is the one that has the path, right? So we can't go horizontal. I mean, we can't go diagonal, I'm saying. We can't go horizontal, left to right, and then vertical, up and down, I'm saying. So yeah, so how can we go solve this guy? So this problem is very similar to a lot of the problem that we've done when we do depth first search on, like, the grid, right? Some kind of board. I'm saying number of islands is a very, very good problem. It's a very good problem too. You guys go check it out. I'm saying I did a problem similar to this, guys. So the algorithm is going to be quite similar. In fact, what I'm saying, just a little bit of change that we're going to do because the constraint is changed a little bit. I'm saying, but pretty much the same algorithm, guys. I'm saying. So let's go. So pretty much we're going to be doing depth first search on the grid, guys. So we're going to be doing explorations on all the characters. So everything, right? Every cell that we get, we're at, right? So we have this one, right? So we would go, we'll visit all the different spot that we can visit, right? Well, there's 4 different spots, so we can go left, right, up, and down, right? So at every cell that we visit, I'm saying that's what we're gonna do, right? So we first start off by, so pretty much we're gonna be looping through the board, right? So we know how to loop through a board, pretty much a double for loop, right? I'm saying as we're looping through it, so we check, right? Does this, so if a character, right, equals to the first character of the string, right? So A, right? So we're gonna go and explore on it, what I'm saying. And then now once we start at A, right, we're going to be going to the next character, right? So we're gonna go to B, right? So at A, right, we like, right, cool. We're gonna check every single cell, right? And then we go left, I'm out of bounds. I go up, I'm out of bounds, right? I go right, I'm good. And then I'm at B now. B as well. It's gonna be going all 4 directions, right? But before we go to B, guys, we need to mark A, right? This spot as visited, what I'm saying. So it's in that path. It's already included, right? So to account for it, to signify that it's already included, right? You're gonna put a dot there to me. All right, this spot has already been visited. So B is gonna be checking all 4 spots, guys. I'm saying it's gonna go left, right? It's gonna say, oh, A is already visited. I'm saying it's already good. So we're gonna backtrack, right? I'm gonna go up, out of bounds, we backtrack. We're gonna go to the right, right? And then it goes to the right, it sees C, I got C, right? Boom, it goes, and then C does the same thing, check all direction, right? Goes to B, B is already marked as visited, so we don't account for it, I'm saying. So we go there, we go to C, boom, that's good. And then we go E, right? Remember, it checks every spot. I'm just trying to speed it up, I'm saying E and then D. All right, and then we found that that word, right? That fully word, then we return true, guys, I'm saying. Just like this one, right? We return true, guys. I'm saying we're able to find it. And this one, we were not able to find it because there's no, so we see A, okay? So they're looking for A, B, C, B, right? A, B, C, right? But there's no B, right? Even though this B is nearby, but it's already included, what I'm saying, because yeah, all in there. So we can't account for it anymore, I'm saying. So there's no A, C, A, B, C, B, what I'm saying. So return false, guys, what I'm saying. So let's go through a quick example of the algorithm's gonna work, guys. I'm saying, so yeah, guys. So that's how we're gonna go about solving it. I'm saying. So we see A. So now, so the word that we're looking for, right, is gonna be for this one, right? AB. This word, right? So now let's do the exploration. So now we'll be looping through the board, right? So we see A, right? A is A. So A is the first character, right, of that word. So now we're gonna go do the DFS, right? I'm saying. So we see A, all right. So we visit A, right? Now we're gonna be visiting all 4 directions that we're allowed to visit. I'm saying. So now we put a dot to signify that it's visited, right? So now now we go up, left, right, out of bounds, and then we go to the right. And we see a B, right? B is a valid path since B is the character that I'm expecting. I'm saying. So I see B, all right? B is good, right? So now I'm gonna count for B. Right, so I put a dot there, guys, just to signify that it's already been accounted for. You know what I'm saying? So we don't keep revisiting things that we've seen already. You know what I'm saying, and that's already included as well. I'm saying. So now we see B, right? We put a dot, right? And then now the next character that we want to see, right? So C, right? So we go up out of bounds. We go F, not the character that I'm expecting. So I backtrack, right? And then I go to the right, and now this is the C that I'm looking for. I'm saying. So I'm at C now. C's there, so I'm like, cool. Let me account for C, right? For this C, first C actually. I'm saying. So I go here, right? Nope, it's already accounted for. I go up, bad. I'm saying I go to the right. Nope, not good because I'm expecting a C, right? I'm saying. So now I go down, right? I see a C, right? And I put a dot, right? I'm saying to say, all right, we're accounted for. I'm saying. So I get to that C, right? And then now so let me go back. I'm at this C now, right? So this is the second C. I'm saying. So now I'm at this C now. So I'm gonna account for it, right? Because I'm gonna be exploring all 4 paths. Remember? So same thing, right? We go up, already accounted for. We go left, already accounted for. We go to the right, not the character I'm expecting. You know what I'm saying. So yeah, this is F is not the character I'm expecting, right? And then we go E, right? E is the character that I want, right? So cool. So I'm at this one now, right? So now I'm gonna be doing exploration. So I put a dot. I'm saying, and then now we go to D. So no, I go to E, right? So I go to E. E is not the character I'm expecting. I'm expecting a D, right? I go up, nope, and I go to the left finally, right? I'm like, all right, cool. D is the character that I'm expecting, right? And then, guys, that's when we know. So since we included all the characters in the string, guys, we know that the path that we have, guys, is indeed the path that we. So we see that this path, right? It's the path that includes that word pretty much that we're looking for. So we will return true, right? If we ever end up finding all the characters, I'm saying, by using all the adjacent cells, right, as we visit the nodes, I'm saying. So this is a very, very good depth of search problem, guys, to really, search every single position, guys, and do it in pretty efficient way. So let's go ahead with the implementation, guys. Hopefully you guys are able to follow the thought process. All right. So let's just quickly do this real quick, okay? So yeah, guys, so we're gonna be using, guys, remember, so first things first, right? What's gonna be the thing that we're gonna do? So we know that we need to loop through the thing, right? The board, I'm saying. So we know how to loop through boards now. So board that length, right? So we're gonna be looping through every row, right? And for every row, guys, I'm saying, we're gonna be looping through every column. I'm saying. It's a very good algorithm, guys. Very, very good. Board I dot length, I'm saying. J++. So once we loop through the board, right? So we check, right, guys? No. So we're gonna be using a depth first search function, right? The same way that we did number of islands and max area of islands, guys. I'm saying. So if the word, right, that we're looking for, chart, right, so the first word, right, of that first character of that word, right, equals to board the ij, right? If it equals, what I'm saying, so there's like a equals the first character, right? That's when we went to the function to. That's why we're gonna be going to this function to do the exploration, pretty much. You know what I'm saying. And then we do and, right? So if it matches, right? So this thing is true, right? Then we're gonna be going to this function, which is gonna be called DFS. And then we're gonna pass in, guys. What I'm saying. So we know we need the board, right? The board, that's the thing that we need, right? We're also gonna be needing the coordinates, right? To know which, I'm saying, thing on the board that we need to reference. I'm saying. And also, guys, we're gonna be passing in the word, guys, which is a very good thing that we need. I'm saying. And also we're gonna need to know the index of that word. I'm saying, which is gonna be 0 initially. I'm saying, to signify the first character. I'm saying. So if that's true, right? If it returns true, right? Then we're gonna return true, right? That means we found that word in the board. I'm saying. And likewise, if it never hits true, guys, then we know that we have not, we're able to find that character in the board, guys. I'm saying, so let's quickly implement the that function way quickly, okay? The DFS function. So the DFS function, right? So we're gonna be passing in the char board. I'm saying, pass that in, right? The next thing that we do, we pass in the coordinate I, right? The coordinate J, and then we pass in the word, guys. I'm saying, string word, right? Pass in the word, and then we pass in the index, right? It's gonna, the index pretty much gonna help us in keeping track of which character that we need to pretty much character we're expecting, guys, so we know that we do the exploration correctly. So now we have the usual edge cases, what I'm saying, to, so when we go out of bounds, stuff like that, we stay within the bounds of the board, what I'm saying, because we're going to be going all over the place, guys, you know, up, down, left, and right, so we need to give it some kind of rules, what I'm saying, to make it, I'm saying, like, you know, so you can give it some kind of order, I'm saying. So now what we're going to do, guys, if I is less than 0, right, that's a edge case, so, and then I is greater or equal to board that length, right? And, right? Or, and then or I or J, right? Same thing, less than 0, or J is greater than or equal to board of I, that length, you know what I'm saying? Or, right? The word that I'm expecting, right? Is not equal to board, you know what I'm saying, of I, J, right? I'm saying, so if that's not the character that I'm expecting, you know what I'm saying, I'm simply gonna return false, you know what I'm saying, to any of those cases, or not the case, I'm saying return false. So now the next thing that we're gonna do, guys, I'm saying, we're pretty much gonna be storing. So all right, so we must have gotten to a good path, I'm saying. So we must have gotten to a good path. So now we're going to be storing the that temporary variable, I'm saying, board of I, right? We're going to temporarily, I'm saying, just store that. I'm saying, because we're going to be overriding it with a value, since we're going to be doing some exploration on there. I'm saying, so now that character, guys, that I put is going to equal to a dot, right? Temporarily, though, I'm saying, because we're going to be doing the exploration. So now we're going to be exploring the neighboring stuff, right? So it's the DFS, guys, I'm saying. Boolean red, right, is going to equal to DFS, right, of board, you know what I'm saying, passing the board, IJ, right, the word, the index, you know what I'm saying. So just copy that, right, I'll show you guys exactly what we're going to do. All right, so now, yeah, we simply return that. So now what we're going to do, right, okay, I told you guys so let's just do index plus 1, right, because no, index plus 1 signifies, so let's say so now, we found a matching, so A is good, right? So now we need to do index plus 1, right? Because we want to, you know, say, all right, cool. We're from A, right? Index plus 1 of it, right? For character signifies character B, you know what I'm saying? So now index is equal to 1, right? So now index equals 1, right? Pretty much saying that now we were looking for a B, right? And we keep doing index plus 1 as we found valid paths, guys, you know what I'm saying? So we're at B, right? So now at B, we're going to be exploring, right? So now we need to do index plus 1, right? So to signify that we're looking for a C, you know what I'm saying? And then so on and so forth, guys, you know what I'm saying? So that's the whole reason why we do that. So the index plus 1. Index plus 1 for all of them, you know what I'm saying? And then now, guys, we're going to be going up, right? We go above us, what I'm saying? Then we go below, what I'm saying? And then we go to the left. And then we go to the right, what I'm saying? And then we have to remember to give the value back, what I'm saying, whatever value it was before. So yeah, we temporarily store in the temporary variable, what I'm saying. And then after that, we should return red, what I'm saying. So obviously you can see that I'm missing a piece of logic here, right? So how do I return true, right? It seems like I'm only taking care of the false case, right? So now how are we gonna know we get a good path, right? We get to a good path, right? If the index, right, equals to, what I'm saying. So it should come before, actually. So if the index, guys, is equal to board index equal to board that length, right? That means that we get to the last character, I'm saying, and then the last character, the index plus 1, right? Let's say, I'm saying, so 0, 1, 2, right? So 3, right? So index would be 3, which would equal to, not word that length, I meant, well, I'm sleepy right now, so word that length, right? Obviously, that's what I meant, I'm saying. So it does that, right? So the length of the word, right, is 3, right? I'm saying, so the index 3 is equal to word that length, right? Then that means that we pretty much found all the characters that we found, like, sequence of characters, right? That's in that are connected, like I'm saying. We found a path, pretty much what I'm trying to say. We found a path that has all the characters, I'm saying, by only using characters that are adjacent to us horizontally or vertically, I'm saying. So yeah, guys, so I think all the logic is going to be pretty good. Let's quickly go over that. So we use the double fold, right, to loop through the character, right? So yeah, so we check I equal to 0, I is greater than board that length, or J, I'm saying. So let's check if we pass these small test cases. All right, cool. We're able to pass the small test case. Let's see if we pass all the test cases, guys. I'm saying, awesome, guys. We're able to pass all the test cases, guys. So I want to thank you guys for taking the time to watch this video. If you guys found value, make sure to give me a like. If you guys are new here, make sure to subscribe, because I'll be doing a lot of other videos just like this one. So I want to thank you guys for taking the time to watch this, and I'll see you guys in the next one.